Hello everyone. On this part we have hypothesis test for a population mean. Here again we have same rules for testing. So first step we should have all these requirements. The first part we should have simple random sample. The next part here is that the sample has no outliers, and the population from which a sample is drawn is normally distributed. What that means, our sample size should be greater than or equal to 30. We had this part before, but we don't know what outlier means. So let's have definition for that part, what outlier is. Okay, I'm writing that part here. So what are outliers? These are unusual values in a data set. And how we can find them? Okay, how find outliers? First step, sort your data. Then second step, looking for unusual high or low values. What that means, for example, if I had these data set, for example, I have negative 123, negative 1, 1, 3, 4, 5, and the one here, 135. As you can see here, these numbers are very close, negative 1, 1, 3, 4, 5, but between all these numbers, the numbers that are unusually high or low, I can have these two, negative 123 and 135. I can say that these two are outliers because these two are unusually high or low between all these numbers. So I can have these as outliers. Okay, back to this part. So the second step was that we should have our population. This should be normally distributed. What that means, our sample size should be greater than or equal to 3. And the third one is that, again, we should have independence. So sample values are independent of each other. Then again, we should have all these 6 steps that we covered in the last part. In step 1 is that finding what a null and alternative is. So this is null and this is alternative hypothesis. Same as before, the first one, mean is equal to. So for all of these, we have equal to. See, two tail, left tail, and right tail. So same rules for all of these using equality. And then for alternative, when you have two tail, you always have is not equal to. When it's left tail is less than, when it's right tail is greater than. But in this case, since we're working on population mean, here I'm using mean instead of. If you remember last time, we had population proportion, and for that part we had P. That's why we used P on this part. But since here we have mean, I'm using mean for all of these. Okay, and what this means, 0 exactly same as having P0 is value of the population mean. Okay, then step 2, we should find what alpha is, and alpha was level of significance. Step 3, finding T, so T0, or in other words, compute the test statistics. We also had to test the statistics and finding Z0. In this case, we have T0. So this is T distribution. So when you had Z0, this was equal to, just writing so you can see what is the difference between population proportion, and here we have mean. So we had this one instead of this board. So this is what the difference is. Instead of sample mean, we had sample proportion. Okay, then step 4, determine p-value. Here we have two-tailed, and our p-value is sum of what we have on left and what we have on right. So the sum of area in tails, and left tail is what we have on left side. It's the area left of T. 0 is the p-value, and last one is when T is greater than T0, so area to the right is our p-value. Then step 5, we want to see if we should reject null hypothesis, and that is when p-value is less than alpha. This alpha is significance level. If this p-value was less than alpha, what that means, we should reject null hypothesis. Step 6, stating our conclusion. Example number 1. Here our null is mean is equal to 100, and that is versus when mean is not equal to 100. Okay. Here on this part, for null I use H0, and for alternative H1. So it's better to change this one to H1 because that is versus this one. So this is null, and this is alternative. And we have simple random sample. Size is equal to 23. We should have n greater than 30, but here is 23. Is obtained from a population that is known to be normally distributed. Okay, so back to this part. See, we have simple random sample, and we should have normally distributed, but we should have this one. We don't have this part. We have equal to 23. So let's see. So part A, does the population have to be normally distributed? So it's asking, do we need to have that population normally distributed to test this hypothesis by using the methods presented in this section? Why? Yes, we should have that population normally distributed, and the reason is the sample size is not greater than 30. See, here we should have the sample size greater than or equal to 30 to have normally distributed. If you don't have that one, what that means, your population should be originally normally distributed. Okay, so I'm writing that. So the answer is yes. And that is because this is a small sample. Small sample size is 23, which is less than 30. So this should be greater than or equal to 3. Okay, part B, if sample mean equal to 104.8 and sample standard deviation equal to 9.2, compute the test statistic. Okay, based on what we had here in step number 3, finding T0, x bar minus mean divided by sample standard deviation divided by square root of n. So T is equal to I'm not writing 0 and 0 here, that's fine because we only have one mean on this part. But if you're writing, that's fine, so you can write this way. Okay, sample mean is 104.8 minus mean is 100. See here, I didn't use 0. That's why I prefer not having the 0 here because I want to have exactly the same thing, but that's fine. Okay, then sample standard deviation is 9.2 divided by n is 23, so square root of 23. Okay, rounding this, the answer is 2.502. Okay, so that was the final answer for part B. Now part C, draw a t-distribution with the area that represent the p-value shaded. Okay, now drawing t-distribution. Okay, so for T we got 2.502. Let's say this is our point, that's 2.502. Here is T. On the side we have negative. Why I'm trying to tell, because here we have is not equal to, and based on the first page, see, when you have null is equal to and alternative is not equal to, what that means you want to have two tell. So here we have two tell. On the right we have positive, here is negative 2.502. So what we have is this part on right side plus what we have on left. So p-value is this part plus what we have here on this part. So it's the sum of the area is the p-value. And here we have two tell. Okay, then part D, we want to find what is the answer for p-value. Okay, here we can use calculator. Okay, so using calculator TI-84, 83. We should use TCDF and TCDF. Okay, let me show that on calculator. So first press second, then verse. So second, words. Then scroll down, choosing number 6 as T distribution to also TCDF. Okay, so here is what we have is after pressing words, scroll down, choosing TCDF. Then enter data for lower. Since here I have 2 TEL, I only need to enter data for 1 TEL. It doesn't matter which one you choose. You can enter data for left TEL or right TEL. So I'm trying to enter for left TEL. For upper we have negative infinite. Then we have negative 2.502. And degree of freedom is 22. So I have these. So I have these data. The degree of freedom is 22 because that is equal to n minus 1. N is 23. So 23 minus 1 is 22. So we have these data. Then enter. Okay, so the answer is 0.010139. Then we should multiply this number by 2 because this is 2 TEL. So multiply that number by 2. Okay, so multiplying it, the answer is 0.02027. I'm rounding to 0.0203. Okay, so what I entered here was -1. I press second, then use divided by to enter E99. As I explained this one before, this is negative infinite. Then comma, negative 2.502. Degree of freedom is 22. I'm writing that part here again. So degree of freedom, this is n minus 1 is 23 minus 1 is 22. So this is equal to, okay, I rounded this one. Then after that, so this is for 1 TEL. You can also use this instead of what you have here on top. So instead of working on left side, you can work on right side and entering data we have. So starting from this point, we have 2.502, comma, going to right side, we have positive infinite. So it's 1E99. And degree of freedom again is 22. So the answer again should be 0.01. It's the same thing. So this is also 1 TEL. Then next step, to find the final answer for this part is 2 times what you got here is 0.010139. Since I rounded that point, again I'm using is not exactly equal to, so the answer is 0.0203. So this is the final answer for p-value. Okay, all right, okay, this is p. Okay, what else I can add here? So Okay, I wanna write the rule that I use on that part for multiplying by 2. Here, when we wanna find p-value for when t is less than value, for example, in number, okay, here we used, okay, this t less than, this number is negative 2.502. I'm using same numbers. Or when t is greater than 2.502. This is equal to 2 times when t is greater than, okay, let's say I use this one array, 2.502. Or we can use that one equal to 2 times when t is less than negative 2.502. But on textbook you may see you have this one only. But the answers are same. Okay, we finished part D. Now part E. If the researcher decides to test this hypothesis at the significance level alpha is 1%, will researcher reject null hypothesis? Why? Okay, we had step 5. So how we can reject null hypothesis? If p-value was less than alpha, then we can reject null hypothesis. So comparing p-value and alpha in this part, p-value we got 0.0203 and our alpha is 1%. So the answer is no. That is because p is not less than alpha. So this number is not less than 1%, and we failed to reject null hypothesis. Okay, then, so that was part E. Now part F. Construct a 99% confidence interval to test the hypothesis. Okay, we did this part before. So exactly same rule, same steps. Here we have 99%. So finding alpha first is 1 minus 99% is equal to 1%. So this part we need to find our confidence intervals. I should find x bar minus plus margin of error. Okay, and then alpha is 1 minus 99% is 1%. And so using that one, alpha divided by 2. 1% divided by 2 is 0.005. Okay, now finding margin of error and then finding lower bound, upper bound to find our interval. Okay, so times standard deviation be divided by square root of n. Okay, finding t when area is 0.005, and degree of freedom is 22 times standard deviation is 9.2 divided by square root of 23. Okay, so here for this part, T is 2.819. Okay, we had this part before, how to find the answer for that using calculator. Okay, so multiplying the answer is rounding it as 5.408. Okay, now we can find lower bound, upper bound. Okay, so for lower bound we have x bar minus e. For upper bound we have x bar plus e. So x bar is 104.8 minus 5.408. I usually should use that is not exactly equal to, because I rounded that number, but that's fine. So that is equal to 99.39. Upper bound. Now we have plus in between. So same numbers. Instead of subtraction, addition. So that is equal to 110.21. But this is our confidence interval. So our confidence interval is, on the left side we have 99.39, comma, on the right side 110.21. Okay, from this part we can also say that, okay, we have same answer as part E. Why we failing to reject? Because our null hypothesis here, mean was equal to 100 based on what we have here for null. I have that mean here in this interval. I have 100 between these two numbers. Since I have mean equal to 100 in this interval, that's why we failed to reject null hypothesis. So again, from part F, we can conclude that why we rejecting that. So we reject since mean equal to 100, this was null hypothesis, is in this confidence interval. Okay, now number 2, in 2007, Apple stock had a mean daily volume of 35.1 million shares, according to Yahoo Finance. A random sample, so our sample is 40 trading days in 2010, resulted in a sample mean of, okay, sample mean. So this is N. Sample mean is 23.6. with a standard deviation of 11.7 million shares. And this one is sample standard deviation. Okay, part A, based on the histograms and box plot, why is a large sample necessary to conduct a hypothesis test above the mean? Okay, on this part here, we can see that based on these two, that the data are skewed, right? See, we have this part of this side of tail is longer. So same thing for this part. But that means our data are skewed, right? And there are, so here on this part you can see that we have outliers. So we have outliers, that's why we need our sample size greater than or equal to 30. Okay, let me go back here. See, here on this part I said that the sample has no outliers, okay, and the population from which the sample is run is normally distributed, or the sample or the sample size is large, and that is greater than or equal to 30. But since on that part we have outliers, what that means, we should have at least this part. So we should have sample size greater than or equal to 30. Okay, so since here we have outliers, what that means, we should have that sample greater than or equal to 30. Okay, so the data are skewed, right? And there are outliers. That's why we need our sample size greater than or equal to 30. Okay, then part B, does the evidence suggest that the volume of alpha stack has changed? So has changed since 2007, use alpha 0.05, and that is level of significance. Okay, step 1. So first, I have here, what I have here is null and alternative. For null we have, okay, what's that? Okay, our mean is equal to 35.1. And alternative, since we have has changed, it's asking if is that one changing. What that means, we don't have any words about increasing or decreasing. So that means that I need to use is not equal to this number. Okay, then step 2. Our alpha is given. Then step 3, test statistic, finding t. So t is equal to x bar minus mean divided by sample standard deviation divided by square root of n. Okay, that is equal to x bar was given is 23.6 and sample standard deviation is 11.7. Mean is 35.1. And n is 40. Okay, so that is equal to negative 6.216. Okay, then step for drawing this. Okay, so I'm following all these steps. So step 4, here we have again exactly the previous part. We should draw this to find p-value. And then step 5, comparing it with alpha. Okay, so for t we got negative 6.216, but here since we have 2 tail is not equal to, what they have on the right side is positive 6.216, on this side negative 6.216. So this is 2-tailed. Test, so our p-value is sum of these 2 parts. Okay, now I want to use calculator to find p-value. So using TI 84, find p-value. Again using TCDF. So exactly same as previous part. Now what I have here, let's use on right tail on this board. So I have 6.216, comma. So starting from this point going to right, we have positive infinite. For positive infinite, entering 1 second, then dividing. So after pressing second, then press division, then enter 99. So this is infinite. Then comma, our n is 40, so degree of freedom is 39. Okay, so as I said, it doesn't matter what tail you're working on, right tail or left tail. So you can either enter this one or enter what I have in my notes. So for lower, you can use negative infinite, upper negative 6.216, or for lower positive 6.216, and for upper positive infinite. And degree of freedom is exactly the same thing. Okay. So this is the answer. Here we have negative 7. What that is, here means I have 7 decimal points. So I'm writing the answer for that part. Okay, here is up to 87. So here we got, based on calculator, I got 1.2978 69963 E, and here -7, which is equal to point. Okay, we have 0, 0, 0, 0, 0, 0. Then I have 1. See, I have decimal point is here. Now I have -7 on that part. That's why I should have 7 decimal points on this part. So moving this decimal point from this part to left side, and this is what we have. Mm, 699. Okay, this is enough. Okay, after that, so we should multiply. So p-value is 2 times what I have here. Okay, so p, rounding it, is this number. Okay, so this is the final answer for P. Okay, then comparing this number with alpha, and alpha is 0.05. Okay, so step 5. Okay, now step 5 is this p-value less than alpha. P, we got that number. So is this one less than alpha? So yes, that's why we should reject null hypothesis. Now step 6, conclusion. What this means. There is sufficient evidence to indicate that mean volume of Apple stock has changed since 2007.